All right, y'all, welcome back. So, what I thought might help you on our topic 3 review is I'm going to make a video going over the problems that are on your Delta Math review. Okay, I don't know why I hadn't done this before. Probably would have made your lives a little bit easier, but I'm going to do it right now. So, these problems are going to be just like what you see on the Delta Math review. They're not going to be exact because all of you get different problems. So I don't know exactly what problem you're going to get, but I'm going to do ones just like it so you'll be able to kind of see how to work them out. All right, so I'm going to go through each one. So feel free to bounce around this video. You don't have to watch the whole thing, skip around, just find the ones that you need. All right, so the very first problem is going to say to plot a point, which I don't think any of us are really going to have any trouble with. So it's going to give you a graph, and then we just plot this point. So the first one says 0, 4. So that's x is 0, y is 4. So that means I'm going to go up 4 and put my point. Okay, so on your graph, you're just going to move the cursor around and place the point. All right. The second question says find the roots. All right, and it gave you a graph. So whenever you find the roots of a graph, it's really, really easy. Another name for roots is x-intercepts, right? So just look at this graph and just pick out all the x-intercepts, right? So I have -8, -4, 0, and 3. Those are my x-intercepts. Now they might want them, it might be points. They might want them entered as points. Okay, that would just be -8, 0, -4, 0, 0, 0. Okay, the next one, question number 3 says find the y-intercepts. Okay, and if you think about where the y-intercepts are, that's wherever x is 0. So like this graph, the very first one that we did, the y-intercept was 4, and that means the x value was 0. Okay, so that's all we're going to do here is we are going to plug in 0 wherever I see an x. Whoa, whoa, whoa. So wherever I see an x. Okay, so if I were to plug 0 in here, right, 0 in for x, that would mean the y-intercept is 3. If I were to plug 0 in here for x, that means the y-intercept would be -5. If I were to plug 0 in here for x, that means the y-intercept would be -1. And we're done. If you're ever in doubt, you can always just graph this on Desmos, right? So go to desmos.com, type that in, and you'll be able to see where the y-intercepts are, okay? All right, number 4 is equation of a circle. Okay, now to find the equation of a circle, you have to know what the equation of a circle is. So r squared equals x minus h squared plus y minus k squared. That's the equation of a circle. All right, and all we have to do is pick out what these things are. They already gave us the info, right? On this example, I think it's actually a picture of a circle. I just couldn't draw a circle good enough. All you have to do is pick out the center and the radius. And remember, the center is always h and k, and the radius is r. So then we just plug them in wherever they go. So r squared, if r was 2, r squared would be 4 equals x is going to stay x, h is 2, squared plus y is going to stay y minus k. But since k is -7, when I plug it in here, it's going to become +7 squared. And that's it. Okay, so just figure out what h and k are and plug them in. All right. Okay, that's question number 4. Question number 5 is very, very similar, but now they are giving you the center and another point. Okay, so this is where we're going to have to figure out what the radius is. All right, so we don't know what r is. That's the one thing that I need in order to do this, right? I have to know what r is. So a center we talked about before is always h and k, and then just a random point is x and y. So to find the center of this, okay, I'm going to use the distance formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and y'all can use all your resources. You don't have to have these formulas memorized. But if you do, it'll make your life a little bit easier. So I'm just going to pick out. I'm going to call one of these x1 and y1, and one of them x2 and y2. Okay, it doesn't matter what you pick. Makes no difference. I'm going to call this one x1, y1, this one x2, y2. Okay, didn't matter if I switch those around. Now we just plug it in. So x2 is 6 minus x1 is 9 squared plus y2 is -5 minus -4 squared. And then we solve this thing. 6 minus 9 is 3. -3 squared is 9. -5 minus -4 is +4, so that's -1. So that becomes a +1 when I square it, so the square root of 10. So r is now the square root of 10, because I just found the distance from the center to a point. And now I just plug it in exactly like the last problem. So remember the equation of a circle? Now I just plug it in. If r squared is the square root of 10, so if I square the square root of 10, okay, then I plug everything else in. X minus h is 6 squared plus y minus k. Since k is negative, it becomes positive. And the last step is that square root and that square cancel out. 10 equals this exact same thing. And we're done. Okay, so that's question number 5 on your test. All right, question number 6. I want you to solve this. You guys have done this over and over and over and over again. It just happens to be fractions, so you don't like it. So we just distribute. So 1 equals 2/3 times 10 would be 20 over 3x. 2/3 times 15 would be 30 over 3, which is 10. And now we solve this thing. You can let your calculator help you out. I would add 10. So 11 equals 20 over 3x. Then to get rid of the 20 over 3, you got a couple of options, right? I'm going to multiply both sides by 3 over 20. So you multiply by the reciprocal. So those would cancel. And you get x equals 33 over 20. So not pretty, doesn't really matter. Doesn't matter if it's pretty or not, right? Just because it's a fraction doesn't change anything that we do. All right. All right, number 7. I hope my computer is not like freezing up here. I feel like it's going really slow. But I guess we'll see. So number 7, we got 3 fractions now. I need to get rid of the fractions. So I'm going to multiply this entire problem by the least common denominator of 9, 7, and 63. All right, which in this case is 63. So if I did that, if I multiplied this first fraction times 63, right? 63 divided by 9 is 7, and 7 times 8 is 56. Same thing here. 63 divided by 7 is 9, and then 9 times 4 is 36. And then on this last one, the 63s are just going to cancel out. So I'm left with 2x minus 8. And now it's just like any problem you've ever done. 56 minus 36 is 20. Then you would add 8, divide by 2. I did that really, really fast, so if something doesn't make sense, please reach out to me and let me know. Okay, but yeah, that was super, super fast. All right. All right, number 8. Again, these are just like what you'll see. Number 8 gives you a proportion, right? When one thing equals another thing. Okay, so if it's set up like this, we could just cross multiply. All right, but your problem might not be set up exactly like mine. So we're going to do the same thing that we did up here, right? I need to get rid of these fractions. The same thing we did right here with the 63, I'm going to do it right here. So I need to get rid of these fractions. So in this problem, The least common multiple of 3 and 2 is 6. So I'm going to multiply each parenthesis times 6. Okay, so 6 divided by 3 is 2, and 2 times 3x minus 6 is what I'm left with. Equals, same thing over here. 6 divided by 2 is 3, and then times x plus 6. And then we solve this like you've solved everything. Right, we distribute 6x minus 12 equals 3x plus 18. Now get all the x's on one side, all the numbers on one side. Doesn't matter which side you do. So I'm going to subtract 3x. And then I'm going to add 12. I ran myself out of room here. So that gives me 3x equals 30. And then I divide by 3. X equals 10. Okay, so question number 8 on your test and your review looks exactly like this one. All right, just be different numbers. All right, number 11, or excuse me, number 9. I don't know why I can't count. Here's number 9. So solve by factoring. Okay, now in order to factor, it has to equal 0. So the first thing I need to do in my problem is add 4x. So x squared plus 3x minus 18 equals 0. And now we just need to solve this. Okay. Now, one thing you can do whenever it says to solve, what I would probably check first is just graph it. Because if you're solving it, you're looking for the x-intercept. So if you graph it and you can see the x-intercepts, then you're good. Okay. If you can't, then you're going to have to do a little bit more work because they're going to be like imaginary numbers, complex answers. But this one we're going to do by hand. So remember when we factor, we make a big X, negative 18 on top, 3 on bottom. And we try to think about what multiplies to get negative 18 but adds to get 3, which in this case would be 6 and negative 3. And then I put them in parentheses. So it'll be x plus 6, x minus 3 equals 0. And then since there's an equal sign, I actually need to solve this. So x plus 6 equals 0. X minus 3 equals 0. So I just set each one equal to 0 and then solve it. So x equals negative 6. X equals 3. Boop. And we're done. Okay, but again, if it says solve, I would just try to put it into Desmos or graphing calculator if you have one and see if it works. Okay, all right, number 10. We're almost done. Number 10 is the quadratic formula. Okay, and I know y'all know this because we played that fantastic song. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we just plug in the numbers where they go. All right, remember, it has to equal 0, which this does. So I have a, b, c. We're just going to plug them all in. So negative b would be negative 3 plus or minus square root. B is 3 squared minus 4 times A is 2. C is negative 8. All over 2 times A, which is 2. So now we just keep solving it. So negative 3 is not going to change. Plus or minus square root. 3 squared is 9. Minus 4 times 2, which is 8. Times another 8 would be 64. All over 4. So then we keep going. Negative 3 plus or minus the square root of 64 plus 9 would be 73. All over 4. 73 is not going to break down any, so we're done. Right, we just plug the numbers in where they go. Okay. Okay, Panky. All right, number 11. Solve this thing. Again, if it says solve, I would try to put this in Desmos, right, and see what you get. But we're going to do it by hand. So the first step, get the square by itself. So divide by 2. So that would give us x minus 4 squared equals 25. And then I got to get rid of that square. So square root it. That way the square root and square cancel. So I'm left with x minus 4 equals, remember when you square root a number, there has to be a plus or minus. So this one would be plus or minus 5, and then I would add 4 to both sides. 4 plus or minus 5. So that's going to give me two answers. 4 plus 5 is 9. 4 minus 5 is negative 1. So 9 and negative 1 would be my final answer to that problem. Okay? Questions? All right. All right. Here we go. So the next one is number 12. All right. So what I am going to do first is there's a number outside the parentheses. So I'm going to distribute it. So 25x squared minus 50 minus 13 equals 1. All right. So 25 times x squared, 25 times 2. Now I have some like terms. Negative 50 minus 13 is negative 63 equals 1. Then I would add 63 equals 64 because I need to get the x by itself. Still not quite by itself, so get rid of that 25. So divide both sides by 25. So now it's x squared equals 64 over 25, which looks kind of ugly, okay? But it won't be that bad because I need to get rid of that square. So to get rid of the square, I'm going to square root it. That way those will cancel. And I'm left with x equals, I square rooted it, so it has to be plus or minus. And then just square root each separately. The square root of 64 is 8. The square root of 25 is 5. There's my answer. Plus or minus 8/5. And we're done. Ding, 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 ding. All right, 3 left. 3 left. Number 13 is imaginary numbers. Just wants us to add or subtract them. In this case, it is subtract. So basically, just find the like terms, right? If they have I, they are like terms. If they don't have I, then those are like terms. So negative 9 minus 10. Negative 9 minus 10 is negative 19. And then 9i minus 8i is just plus I. 9 minus 8 is 1. And we're done. Right, just find the like terms and put them together. Capiche? All right, number 14 says negative 4 plus 9i squared. Remember, when something is written with a square, that means we can write it twice. And then we do what you've always done. We just distribute. Negative 4 times both. So negative 4 times negative 4 is 16. Negative 4 times 9i is minus 36i. And then we do it again. So 9i times negative 4 is minus another 36i. 9i times 9i is 81i squared. And now we just look for like terms, right? These two in the middle would make it negative 72i because they're both negative. And then the one thing that you probably have forgotten is I squared. Remember, I squared turns into negative 1. Okay, I squared is always, always, always negative 1. So I'm going to put a negative 1 in for that I squared. And then the 16 hasn't changed yet. So now we can kind of finish this thing up. 16, 81 times negative 1 becomes negative 81 minus 72i minus 81 because those two became negative 81. All right, and now I just combine the like terms. 16 minus 81 is negative 65 minus 72i. And we're finished. Okay, so just remember I squared is negative 1. All right, the very last problem, number 15, says find the roots, and it gave us this equation. So we, once again, these are going to be imaginary. So we are going to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And again, I know what a, b, and c are. A is 1, b is negative 16, c is 80. All right, so let's plug all this in. X equals negative b plus or minus square root b squared negative 16 squared minus 4 times 1 times 80 all over 2 times 1. Right? I'm going to need my calculator just like probably some of you will need it as well. Then we just simplify. Negative 16 becomes positive 16. Square root 16 squared. 16 squared is 256. Double check my math. Minus 4 times 1 times, this should be 80, not 8. Minus 4 times 1 is 4. Times 80 is 320. Minus 320 all over 2. Okay, so now we simplify a little bit more. So 16 stays the same. 256 minus 320 is negative 64 all over 2. And now we can keep going. The square, well, you can't even see this other side. So 256 minus 320, the square root of negative 64. Okay, this is where those imaginary numbers come into play. So the square root of negative 64 is plus or minus 8i. The square root of 64 is 8, but since it's negative, I have to put an I. Okay, and then the whole thing is still over 2. And now you should notice something about all these numbers, 16, 8, and 2, right? They're all even. So I could divide all of those by 2. And if I did that, it would get rid of the 2 on the bottom because 2 divided by 2 is just 1. And it would leave me 8 plus or minus 4i. There is your topic 3 review. Okay, these questions are exactly like what you're going to see on the test. So if you are confused, feel free to jump around, look at